yesterday we talked about just simplifying with our trig. Well, today we're going to keep simplifying, but we're going to kind of take it a step further. So we're going to look at potentially multiplying or factoring trig expressions. And the reason why multiplying can be helpful is because it lets us simplify things like when we have fractions. So I have two fractions here, and it asks us to perform the addition, and then we're going to simplify. So, just in general, when we have fractions, what do we have to do in order to be able to add them? Yeah, we have to have a common denominator, and the same thing is going to be true here. The only difference is that our common denominator is going to have trig things in it. So notice that our two different denominators don't have anything in common. So I just have to multiply this one by 1 plus cosine, and this one by sine. But remember, am I allowed to just like multiply the bottom? Because we want to.
Multiply the whole thing.
Yeah, we'd multiply the top and the bottom, because now if we do that, we didn't change the value because I just multiplied by 1. We just want to change what it looks like. So then we're just multiplying. So on our first one, I have sine squared of theta. And then I'm just going to leave our denominator in factor form. We're still adding. Now notice that my cosine is being multiplied by all of that. So what do I have to do? So like when I have something that's in the front of a parentheses, what do?
Distribute it.
Yeah, so I have to distribute it. So I have to multiply it to both of those things. So I have cosine of theta plus cosine squared of theta. So now are our denominators the same? Yeah, so now we can make it into one fraction. And remember, we add the numerators, but we're going to leave the denominator the same. Okay. So we did the first part of our instructions, which said to perform the operation. I added my two fractions together. However, my second part says to simplify. Is that very simple right now? No, not really. Okay. But something that we do need to be careful about is notice what operations do we have on the top? Addition, right? So these are not factors, these are terms, which means that I cannot reduce a sine squared with a sine, and I cannot reduce this cosine with this cosine, because they're being added on top. But whenever we see division and we see things that look the same, we want to just start reducing stuff out. So be careful, because you don't. But we do eventually want to reduce some out, but we do have to do a little bit of rewriting. So what else do we notice about our numerator?
Squared.
It does. And which of our identities has squares in it?
Pythagorean.
Yeah, so I'm going to go ahead and put my two squared terms next to each other. That's just rewriting, because they're all adding, so I can put them in whatever order I want. And by our Pythagorean theorem, what does sine squared plus cosine squared equal?
1.
Just 1. Yes, one baby. So now that I've gotten rid of the extra stuff, now I have a 1 plus cosine on top and a 1 plus cosine on bottom. And so now I am able to reduce that. And I'm just left with a 1 on top divided by sine theta. Which is much simpler. However, I still have a fraction. So could I rewrite that as not a fraction? It is also equal to cosecant. So that would be our final answer. So there's a lot going on with a lot of these. So not only do we have to remember our new trig identities, but we also have to remember like our fraction stuff and like common denominators and things like that. So this is combining a lot of skills. So that's usually if people struggle, that's kind of where we struggle a bit. It's not necessarily remembering the identities, because once you memorize those, it's pretty straightforward. But it's like applying them as well as using our algebra skills. Speaking of algebra skills, we can also factor things that have trigs in them, which we've done factoring in here before. That's why it's important to read our directions, because like the first one said to perform the addition and then simplify. This one doesn't ask us to simplify, it just asks us to factor it. But I think sometimes it can help. So like right now I have a secant squared. The secant can kind of, or the trig function in general can make it a little bit hard to tell what to do. So I think sometimes it's helpful to like rewrite it just as a variable, because we're used to factoring things with just a variable. Yes? Okay, so if I had b squared minus 1, how would I factor that?
Difference of squares.
Yeah, so what does our difference of squares tell us?
X plus 1x minus 1.
Hmm? Or whatever my variable is, yes? And like I said, our secant is kind of acting as our variable here. So I can still apply a difference of squares. So it's going to be secant of theta plus 1 and secant of theta minus 1. Questions on that? Okay. What other types of expressions have we spent a long time factoring? So this is a binomial, right? There's two of them. Polynomials, but specifically trinomials, right? So we're also going to see lots of trig trinomials as well. But luckily they're going to factor pretty similarly to how our other trinomials factor. So again, this time we have tangent. So just like last time, it can be helpful to go ahead and just write my tangent as some variable. It doesn't really matter what variable. But it's just easier to factor this than it is tangent. And you can factor within that, it's just you're going to be writing tangent a whole lot in order to be able to factor it. So looking at 4b squared plus 4b minus 3, how would we factor that? gives us negative 12. So we want two things that multiply together to give us negative 12, that add together to give us a positive 1. What do we think?
4 and negative 3.
Cool. And then remember that if our leading coefficient is not 1, our like step or kind of trick here that we have to do in the middle is then to take those and we break apart our middle term with those two numbers. And then we factor by grouping. What do our first two have in common? 4b. And we're left with ab plus 1. And then what do our second two have in common?
Negative 3.
Yep. And so then we're also left with ab plus 1, which remember is what we want, because I need my two parentheses to be the same, so that way we can factor out that b plus 1. And we're left with 4b minus 3. Except, did we have b's in our original expression? No. But again, it's going to work the same way. So instead of a b, I'm just going to put our tangent of x. What questions do you have there? I just have a little bit left. So I have another trinomial here. So what's different about this trinomial?
There's two trig functions.
Oh, okay. So basically this would be like if I had a b squared minus a minus 3. Can I factor that right now? No. Because they're not the same, yes. But what have we been talking about that lets us rewrite one trig function as another trig function?
The trig identities.
Our trig identities, yeah? So, the cotangent, really the only one we have for that one would be our quotient identity. And so we don't really want to add in fractions if I'm trying to factor, okay? But I have a cosecant squared. Do we have a Pythagorean identity that would let us rewrite our cosecant squared?
1 plus.
And the nice thing about that is now we have a cotangent squared, which is the same as our cotangent.
I just have screen. Thank you.
So we have 1 plus cotangent squared now. Our minus cotangent is still there, and our minus 3. So then, do I have any like terms?
1 and 3.
Yeah. Which gives us
Negative 2.
So again, now I have something that looks like that, which is good because now they match. So our leading coefficient is 1, so that makes it a little bit easier. So what multiplies together to give us negative 2? That adds together to give us negative 1.
Negative 2 and 1.
Correct. Negative 2 and a positive 1. But just like before, I want my cotangent to take the place of my variable. Yes. What questions do you have there? Alright, we have one last one. This one says to factor, and I'm gonna say factor and simplify this time. So I don't have a trinomial this time. But can I still factor? So if we remember all the way back to the beginning of the year, what was the first thing that we said that we want to look for whenever we're factoring things? Not like terms, but it's another word for like. Another word for same.
Common.
Common. Common what? Common factors, right? We want to look for our greatest common factor. We want to look for, do they have two things or something in common? Do my two terms have something in common this time? Yeah, they have a sine squared x. So we can factor that sine squared x out this time. And we're left with a cosecant squared of x minus 1. So if it just asks us to factor, that would be our answer. But that would be the answer if I was just factoring it.
Yes.
But then I said let's simplify it as well. Okay? So we wouldn't want to leave it like that if I said to simplify it too. So if we were gonna simplify it, what do we notice? Okay, it does have sine, and it has our reciprocal of sine. So it might be helpful for us to switch to sines here in a bit.
They're squared.
They're squared? What does that mean? The Pythagorean identity? Okay, which one do we want to do the Pythagorean identity on? Does that look like any of our Pythagorean identities?
Maybe reciprocal.
Okay, we can do a reciprocal. So we said that cosecant is the reciprocal of sine, yes? So this would be 1 over sine squared of x. Yes? Fine. So then we are going to need to distribute in order to simplify. So what is sine squared times 1 over sine squared?
Will this be 1?
Yeah. Okay. And then I would have to multiply it to my negative 1 as well. Okay. So now I just have 1 minus sine squared. What are we going to do with that? What identity has a 1 and a sine in it? Or a sine squared, sorry.
Sine squared plus cosine squared equals 1.
Okay. So again, remember that this is an equation, so I can solve that for anything that I want. And I want it to look like this. So I want my sine squared and my 1 to be on the same side. So how would I move that to the other side? Yeah. So what does 1 minus sine squared of x equal? Yeah. So this just equals cosine squared of x. Are we all okay with that? Now, how I would have done it, which is okay that y'all didn't, because there's usually more than one way. Do we have a Pythagorean identity that has cosecant and 1 in it? Yeah, 1 plus cotangent squared of x equals cosecant squared. So notice that we could have done something similar. Yes? So then my cosecant squared of x minus 1 equals cotangent, right? And then cotangent is cosine over sine, so then our sines would have also reduced, and we would have still been left with cosine. So, whichever way you see it, as long as you are using your identities correctly, there could be more than one way to do it. Which is why writing out your steps is going to be important. Okay? Also writing them out in such a way that like I can follow them logically is going to be important for like your formative assessments and for your like tests. That way then I'm not trying to like piece together where you started and where you ended up.